Mr. Rhodes said we shouldn't sing My Country Says a Thing because we're just making a joke, and it shouldn't be a joke, and it would hurt his ears. But he did say a great idea that he tries to get every person to do, the student body president, is during the moment of silence to just hang up and not say thank you, have a good day, so everyone's just standing there with the longest moment of silence ever, and you don't know when to sit down. Like, that's a genius idea. You should do that. No, do it when we're not expecting it, so we're all just They heard us. Hello? You're fine. Chloe, do we want the pumpkins they're carving in art class for the Halloween dance? That would be fantastic. Yeah. Yeah, that would be great. Thank you so much. All right, we'll be there tomorrow. Bye. Now we have to put on our list to go get pumpkins. What if Tucker carved a pumpkin a couple weeks ago? Okay, last week I think, and it is not good. Like it's just like gross. No, I mean like he did a good. I don't mean like the carving isn't good, but it's just like decomposing so quickly. Like it's it's awful. And I was like, I don't think it's gonna make it to Halloween, buddy. I don't mean like it was awful. Gosh, I didn't mean that. I realized that when you all started laughing. He didn't really carve it. My husband carved it. He did the design. Right? A Minecraft face with evil eyes. But now it looks like, and he had sharp teeth. The very next day, his teeth were not sharp anymore because they were all wilted over. And now it just looks like an old man with no teeth. And the inside's all black and gross. Did you make this many points on your line? So, I kind of ruined these notes a little bit by what we did already, but I'm... What happened?
What did the dog last night? She ran over it.
She broke its leg and just left it.
No, I did not.
She said she ran it over it. Dude, there's too many possums.
I've killed so many animals in my car. I don't know.
Armadillo.
We still have to like 60.
Where were you that you was armadillo?
Oklahoma.
I was like,
My first roadkill too, so I'm like bawling, ants taking the wheel because I can't cry. I'm like hyperventilating. I'm so mad.
I killed a raccoon once, and all I think about when I hit an animal is like, oh, they've only got babies at home, and
One
now
last animal.
their animals are just gonna sit at home and wonder where their mom lives.
Ran into my car one time.
And I feel terrible. But
Ran it back into my car.
You've told this story 3 times in this class alone.
what do you see here? I already told you some stuff you see, right? Okay, they're parallel, but not all inverses when you grab them are parallel, so that doesn't count. Something else you see. What do you notice about the points? That's what I want you to see. We just said this, right? This is the point 0, 2. What do you notice about this graph? This is the point 2, 0. This is the point negative 2, 0. Look at this point. 0, negative 2. All of the points will always switch, right? So, oh look, it's 30 there. You don't have to write all this down necessarily, but all the points switch. The other thing is that they'll always be symmetric about the line y equals x, which works out really cool when it's linear. The line y equals x is right here. And if you know a function to graph its inverse, you can just flip it over that line and it will always be its inverse because when it's symmetric about the line y equals x, it means the x's and the y's all switch places. So, that kind of goes to the next problem. What, Dylan?
Oh yeah.
Nolan and I spent lots of time painting pumpkins to look like a minion, and then we were working on painting this other pumpkin to look like a Minecraft guy, and then it and then they're all washed off now. I was like, well, that was a waste of time. Should have used waterproof paint.
Where were they at?
On the porch. Yeah.
There's like nothing.
Why didn't you bring inside?
I didn't really think about it. Okay. Now they're just sad, half-painted pumpkins.
Next to the rotting.
Next to the rotting pumpkin. But it's alright. I'm gonna be the Halloween maze, not even at home to pass out candy.
Huh?
Unless my husband brings the kids back to pass out candy. Alright, are we good? They could come to me. They would be scary, probably. Look at this lovely picture I drew. Dylan, this is you. Come up here and graph the inverse of this. Yeah, you just gotta flip it over. Come try. Go away. So, definitely if this point is here at 2, 0, then this point should be here at 0, 2. And then it's kind of, to me, it's a visual thing of like, you can just flip this over here, flip this over there. It's not that much of this in this book. There's a little bit. Maybe I give you one problem today about that, but I think it's kind of cool to think about the symmetry of them when you're doing inverses. The real goal today is finding inverses.
Here.
Alright? I got 3 more examples and then we're done. Again, everything with an inverse comes back to the fact of you switch the domain range, which means switching the x and the y. So I gave you some steps here in case you don't remember them from doing inverses. When you want to find the inverse of a function, you just switch the x and y and solve back for y. So I wrote, remember that f of x is the same as y. So step 1, remember to just change that to y. Step 2, switch them, right? That's the definition of an inverse. And then you just got to solve back for y, put the notation in it. So it says 4 steps, but it's really not that many steps here. If you just automatically know that that's why, you don't even have to do that first step. But f of x is the same as y equals 1 minus 3x. If I want the inverse, I'm going to switch it. So that now becomes x equals 1 minus 3y. And then we want to write that as y equals. So you switch them, and then you just do the algebra to get y by itself. So this is linear, so a linear function is going to have a linear inverse. So I'm just going to subtract 1, and I would get x minus 1 equals negative 3y. I'm going to divide by negative 3, which you can just divide everything by negative 3, but if I was going to graph this, like I'm going to separate it as like mx plus b. So I'm going to write that as y equals negative 1/3 x plus 1/3. Right? X divided by negative 3 is the same as negative 1/3. If you wrote x minus 1 all divided by negative 3, that's the same thing. And I think proper notation is kind of important. Show me that you know this is the inverse. So my last step is use the notation for inverse. So instead of saying y equals, say f inverse equals negative 1/3 x plus 1/3. And you can definitely combine some of those steps, like automatically at this step you could have put that in there. Automatically you could have just switched x and y around over here. Get vague memories of finding inverses before. Remember that in order for a function to have an inverse that's also a function, it has to pass the horizontal line test. So when you look at the second problem here, so here, this is my answer. So when I look at this, it says f of x equals x² plus 9, where x is greater than or equal to 0. That always throws people off. What does that mean, x is greater than or equal to 0? Does a parabola pass the horizontal line test? If I graph x² plus 9, if this was 9, it would look like this. That does not pass the horizontal line test. So what they do is they tell us, well, hey, let's only talk about the positive half of that. Does that pass the horizontal line test? Yes. So that just means they're restricting the domain so that it fits the quota there of being a function. So we still do the same thing. We kind of ignore this for now. So if I said the easy part. Just switch them. What would I do next to get y by itself? Subtract 9. So I get x minus 9 equals y squared. Then I would square root both sides. And when you square root both sides of an equation, what do you have to do? What do you have to remember? Plus or minus, maybe if you're using pen, don't write that yet, but if we solve this equation, and this wasn't there, this would be our inverse. We would get a positive square root and a negative square root. And think about if you graphed that. A positive square root, let's see, that's minus 9, so that would really be like over here. Positive square root would look like that. Negative square root would look like that, and it makes a sideways parabola. Is that a function? That does not pass the vertical line test. So since they told me to only pick, oh look, I did that the opposite way. That's supposed to be over here. Sorry. Minus 9 actually means over here. Sorry. If they told me I only want positive values when x is greater than 0, do you think I keep the positive root or the negative root? So it's just going to be the positive root of x minus 9. If that would have said x is less than 0, you would have kept the negative root. And so kind of a good rule of thumb is kind of just don't pay that much attention to that, but it really does affect your answer if it would have been a plus or minus answer. Okay, so just be cautious with it. Maybe you just would have forgot your plus or minus anyway, and all would have been great. Okay, ready for the hard one? Always end with the good one. Probably gonna see that on your test tomorrow too. Quiz tomorrow. This is much harder, right? Find the inverse. Good thing it says not to graph, because who wants to graph this? Step 1, switch x and y. Well, I'll rewrite it. Y equals 2x minus 3 over x plus 4. So that's going to become x equals 2y minus 3 over y plus 4. I need to get y by itself. That means y completely by itself. You can't have a y on one side and a y on the other side. What's a good first step to do here? There's a fraction here, so if I can multiply both sides by y plus 4, so over on that side I would now have x times y plus 4x. I'm just going to distribute that x to both of those. And over here the y plus 4 cancels, so I get 2y minus 3. I feel like we did something similar to this at some point. If it was about inverses, but we had something with functions and trying to solve something on a problem, on a test. I want to get y by itself. So to me, it makes sense. All the y's should go on one side. Everything without a y should go on the other side. So this is a y. I'm going to move it over with this xy. So I'm going to subtract 2y over here. 4x does not have a y, so I'm going to subtract 4x to the other side. So get all your y's together, everything without a y on the other side. So I have xy minus 2y equals negative 3 minus 4x, or negative 4x minus 3. So we switched our x and y's, get rid of the fraction, get your y's together, and then you have to remember from here, what am I going to do to separate this y from the x and the 2? I'm going to factor it out. I can't divide it, because if I divide by y, then I'm still going to have a y over here. Like it's never going to get solved for. So what you want to do is factor that y out, and you'd be left with x minus 2. The home stretch here. How am I going to get y by itself? Divide by x minus 2, and I'm going to get y equals, or even save myself from rewriting it again, f inverse of x equals, it's going to be a fraction, a rational problem just like the beginning one, negative 3 minus 4x over x minus 2. I think that's the one that's on the quiz tomorrow. Find the inverse of that. There's only 2 problems on the quiz tomorrow. We'll go over homework questions in the morning, and then we'll maybe make sure we don't have questions over those kinds of questions before we do it. Okay? That's it. That's your homework. 26, 27, 29, 33, and then 45 and 47 are the graphs. And it's like lots of crazy